Good morning, guys. Mr. Carver here. Let's do section 4.1, and it is entitled Indefinite Integration. And we should start off by talking about this term here. Integration and differentiation are opposite operations. So the first three chapters of the book, you spent taking functions and deriving them, or using differentiation to find the derivative of them, and now we're going to be going in the opposite direction. We're going to use integration, or we are going to integrate functions to find the original function from the derivative. So for instance, let's start off with an example. If I have y is equal to 5x to the fourth, let's make that y prime, that being the derivative of some function, you can probably see fairly easily that the original function, or y, is equal to x to the fifth. And I guess I should say that that's just one possible function that y could be. It could be y is equal to x to the fifth plus 1, plus 11, plus pi, plus e, etc., because this number right here is just the vertical shift. And if you recall, if you've got equal functions, the vertical shift does not impact the graph of the derivative or the function of the derivative. So the way that we're going to write it is, to cover all of those bases, is we're going to say that y prime not y is going to be equal to x to the fifth plus c. And this c is a constant of integration, and it covers all possible answers or all possible vertical shifts of the original function. Now, I should also stress that you do not want to forget that constant of integration, because you will be penalized on tests and quizzes if you do forget it. And I can tell you from experience, it is the easiest thing to forget in this process, but it's a very important part of the integration process. Now, by the way, I should also mention that the term indefinite integral is due to the existence of the c. Since you can't say definitively what y is, that hedge there makes it indefinite. Now, there will be problems eventually when I do give you information that allows you to solve for c, but for right now, we're going to leave it as c. Okay, let's move on. The notation is something that you need to get used to in this section. And here's the way it's written. If I start off with 5x to the fourth, and I tell you that that is y prime, if you recall from last chapter, y is really dy dx, y prime is really dy dx, 5x to the fourth. And if you recall from the last section of chapter 3, we sometimes wrote those in differential form. So if I bring this dx over to the other side, I get dy is equal to 5x to the fourth dx. So this is the derivative written in differential form. Well, that's the way we're going to write it in this chapter and from this day forth. 5x to the fourth dx. And what we're going to do is we're going to anti-derive it, or we are going to integrate it. Those mean exactly the same thing. And the notation for that is like this big, tall, thin S that goes out in the front. This is called an integrand. And what it means is to find the antiderivative of what follows. And what follows is the derivative written in differential form. Now, when you write the answer, you're going to be telling me that it's x to the fifth plus the constant of integration c, and that is your answer. Now, some students wonder what happened to the dx. Well, the dx signifies that the red underlined area, this part right here, is the derivative of some function, and the dx signifies differential form. So when you go back to the original, you no longer have a derivative. That disappears with the dy. And you're left with just the answer, x to the fifth plus c. Okay, so now let's look at some basic integration rules. The first is this. If I've got the integral of, let's do x to the nth power, the answer to that is going to be x to the power plus 1 over power plus 1. We should write that a little more clearly. That's power plus 1 over power plus 1, of course, plus c, the constant of integration. Now, if you recall, back in Chapter 2, we had several items on the prohibited list that you were not allowed to derive. That is going to exist in Chapter 4 first, because we're going to take this one step at a time. So the items on the prohibited list are products, quotients, or quantities other than x, raised to a power, which I think makes sense. If you are unable to derive products, quotients, or quantities other than x raised to a power until you get to those rules, I think it makes sense that as we're anti-deriving or going the other way, those items should also be on the prohibited list until we get there. And get there we will. Okay, let's work a few examples here then. Let's say that I've got the integral of 4x cubed dx. Now, if you recall from Chapter 2, constants did not get in the way of deriving. So the same thing is going to happen when we integrate. And constants may move through the integrand. So you can rewrite this as 4 times the antiderivative of x cubed dx. And now what we're going to do is follow the rule that I just told you about. We're going to take the 4, leave it on the outside because it's like the constant multiple rule, and we're going to multiply it by what we get when we anti-derive this function right here. According to the rule, it's going to be x to the power plus 1 over power plus 1 plus the constant of integration, c. Now if I simplify this, this is going to be 4 times x to the 4th over 4 plus c. These cancel, and my final answer is x to the 4th plus c. Now the beautiful thing about this section is you can take this answer and you can check it by deriving that answer, and you should get back to the original. Easier said than done in some cases, but at this stage in the game I think it's worthwhile. How about something like this? Let's say I've got x squared plus 2, and I want to square that quantity, dx. This derivative is also on the prohibited list. It is a quantity other than x raised to a power. So just like we did in the first part of Chapter 2, I'm going to take that and FOIL it out. That's x to the 4th plus 4x squared plus 4 dx. And now I just have a very long slope machine, or derivative. And just like in the early stages of Chapter 2, this is not on the prohibited list. I can do these each individually. Now you can just anti-derive them or integrate each one of those individually, or you can rewrite them so that they are each integration problems on their own. And I'm going to move that 4 out to the front. And I'll leave that in there just so I can clearly see what that function is. Now, when you break these up, you're regarding each one of those as as an individual derivative, so they all get a dx, which doesn't impact how the problem is worked. So let's go through these one at a time. The first function there, x to the 4th, is power plus 1 over power plus 1 plus 4 times power plus 1 over power plus 1 plus 4. Now, if you think about this function right here, that is the slope machine of this function right there. You can also think about it as being 4x to the 0 power. So power plus 1 over power plus 1 plus then the constant of integration. And then, of course, I want you to clean this up. This is 1/5 x to the 5th plus 4/3 x cubed plus 4x plus c. I realize that's not a lot of integration, of simplification, but I think it's easier to see if you take the fractions and move them completely out to the front. And, of course, eliminate any negative exponents. All right, let's see. What do we do? Let's do this one. Integral of x squared plus 3 over the square root of x dx. And again, I think that you'll notice that many of these problems, at least in the early stage of the book, or this chapter rather, they're going to look a lot like the problems that you saw in the first section of chapter 2. The only difference is you're just going the other way. All right, this is still on the prohibited list. This is a quotient, so I'm going to take this, and I'm going to move that denominator up to the top. That's x squared plus 3. That's times x to the negative 1/2. Let's write that a little more clearly. X to the negative 1/2 dx. The problem is this is still on my prohibited list. I now have a product, so I'm going to take that x to the negative 1/2 and I'm going to distribute it to both of those. This gives me x. Remember, power, if they have the same base, you add the exponents, so that's 4/2 minus 1/2. That is 3/2 plus 3x to the negative 1/2 dx. And then I'm going to split these up, but I'm not going to rewrite them separately. I'm just going to integrate each one of those individually. So the first one is x to the power plus 1. That's 5/2 over 5/2. This is going to be plus 3. X to the power plus 1 is positive 1/2. That's over positive 1/2 plus c. Those are complex fractions. I'd like you to copy dot flop them. This is 2/5 x to the 5/2 plus 6 x to the 1/2 plus c. And that is my final answer. Okay, let's do some trig. Let's see here. Now, it is important to remember the derivatives, or review rather, the derivatives of trig functions so that you can go the opposite way as well. Something like this, the integral of the cosecant of x times the cosecant of x plus the cotangent of x dx. The problem is I've got a product here, so I'm going to distribute the cosecant to both of those, which gives me the cosecant squared of x plus the cosecant of x times the cotangent of x dx. And now you have to think about what gives you this derivative. Cosecant squared. That's the cotangent, which gives you the negative cosecant squared, so that first answer there should be the negative cotangent of x. The cosecant cotangent is the derivative of the negative cosecant of x, and I have to have the constant of integration there. Now again, I think it's important, especially with trig, to derive them to make sure that you do get to here. So I've got the negative cotangent, which is the negative cosecant squared. Check. Minus the cosecant of x, that's negative cosecant cotangent, which is the negative cosecant cotangent. Check as well. That's my answer. One more, guys. Hang in there. How about the integral of the tangent squared of x dx? The problem is, this is not a derivative of anything that's on your list or on your flashcards that you review daily. So what we're going to do is try to transform this into something that we can integrate. And if you recall, the secant squared is equal to the tangent squared plus 1, which means that the tangent squared is equal to the secant squared of x minus 1 dx. And what I'm going to do now is anti-derive each one of them, or integrate each one of them. The integral of the secant squared is the tangent of x, and the integral of 1 is the function that has a slope of 1, which is x plus c. And that is the final answer. You know what? I think I want to do one more. I'm on a roll. How about this? The integral of 1 over 4x, the quantity squared. This breaks several of the prohibited items on the list. That is a quantity other than x raised to a power, and it's a quotient. So let's clean up the bottom here. This is 1 over 16x squared dx. I think I'll take the 1/16 out to the front just to clean it up. This is 1 over x squared dx, but that's still a quotient. So I've got the 1/16 out front. This is x to the negative second power dx. And now I'm good to go. This is 1 over 16. That's x to the power plus 1 over power plus 1 plus c, which is going to give me an answer of negative 1 over 16x plus c. And that is the final answer. All right, guys, listen, best of luck with this section. I will see you tomorrow.